Hi, my name is. Okay, my name is Marcin, founder of Open Source Ecology.
I'm Catarina from the Open Source Hardware Association.
Okay, so today we'll talk about a new breed of industrialists and the revolution they have set in motion. But before we go there, we'll go back to the first industrial revolution and two events that have changed the course of the world. So in 1777, James Watt began selling his new steam engine. It was twice the efficiency of anything before in the market, a major breakthrough at the time. And he patented his invention and protected his patent fiercely. So about 30 years later after that, another man named Richard Trevithick took his new design to market, and in his case, he did not patent his invention. So the miners, the tin miners in the county of Cornwall in England were really glad to see this, as they had problems with James Watt's design, trying to maintain it. So they started to innovate on an open design and make improvements as time went on. And a very interesting thing happened. So here we have a graph of the efficiencies, the gains in efficiency, both in James Watt's time and in Trevithick's time. And in James Watt, the efficiency rose about 4% per year in his time, compared to more than twice that, about 9% in Trevithick's time. So the other point to remember there is that the number of patents that the Cornish miners took out at that time was just 15, compared to almost 1,000 by James Watt and company. So we've seen that the number of patents was inversely proportional to the rate of innovation. So we might ask the question, was that high rate of patenting also responsible for decreasing the rate of innovation? Well, the historical evidence, if we look more deeply into this problem, it appears that that was indeed the case.
So several decades later, Henry Ford was ready to begin production on a brand new car model. Up until then, cars had been expensive machines only the wealthy could afford. But Ford's new model cost half the price of the average car at the time, and he called it a car for the common man. However, in order to begin production, Ford needed the approval of the Association of Automobile Manufacturers. The association held the patent for the automobile, and no one was allowed to produce one without their approval. So Ford requested permission and was denied. He began producing his cars anyway and was in turn sued for royalties. The court sided with him and ended the monopoly for the automobile. The result was a boom in the car industry. Ford's company was one of the first in the city of Detroit in the United States, but within 2 years, more than 100 car manufacturers had appeared. So Ford's low-cost model made it accessible to a whole new market segment, and everybody wanted one. His cars were bought by traveling salesmen, by artisans, by farmers, people who had never dreamed of being able to afford a car. In fact, the car became so popular that Ford couldn't keep up with demand. He also wanted to make it cheaper, and back then, the way to make cheaper goods was to produce more of them in less time. So Ford began streamlining the assembly line. Under the old production model, it took over 21 hours to assemble a car. With the new assembly line, it took only 1 hour and a half. So both of these stories are about making technologies available to a greater number of people and the wave of innovation that follows. They're about the extraordinary things that happen when monopolies are broken and people are given the freedom and conditions to unleash their productivity. However, even though the assembly line brought us the 8-hour workday and cheaper products, it also brought about the age of mass production. And with it, one size fits all and the consumer society. Artisan and small-scale production simply weren't cost-efficient, and because of that, manufacturing became the realm of professionals and large corporations. But now we're on the brink of a new industrial revolution. This is a transformation that both repeats and inverts these events of the past. It hinges on the democratization of some very powerful technologies that may very well disrupt manufacturing as we know it, and transform entire economies, but also in a very old and very new way to produce, the collaborative economy.
Okay. So the internet has changed the way in which we communicate, work, and play, and new business models are rising on top of that. Things such as Airbnb, which is right now, well, it allows people to rent houses and rooms directly to one another. It's a 1.5 billion market worldwide, and $56 million in the city of San Francisco alone. Services like TaskRabbit, which allow us to hire others directly without a middleman for all kinds of tasks. And this is used by some people as their full-time job even. And then there are services like Kickstarter, a crowdfunding platform which allows people to give money to projects directly without people getting loans from banks. And that's providing $100 million of project funding to different people around the world. So this is part of a mechanism where we're getting into working directly with one another, skipping the middleman, and building enterprises upon these peer-to-peer networks in a way that was not ever before possible. So what's become known as the sharing economy has become almost a $4 billion a year market. So the same technology that's used to generate these new economic models and to consume together can also be used to create and design together. So just like the Cornish miners began exchanging information and publishing in a journal, now we can have that same opportunity to collaborate, but on a much broader scale. So a huge part of this is the concept of open source hardware. And that is a research and development method for product development in which people publish their designs openly, they share them so that anyone can download them, play with them, change them, and use them for their own ends. Now, just to show you, here's how it works. So you've got, say somebody comes up with an idea, say for a bicycle. Then you prototype it, you build it, put the plans online, then others can copy them, build an exact replica from those plans. Or someone can take those plans and modify them for their own tastes or for improvements. Or you can manufacture them and sell them at a profit. Now, these improvements typically want to go back into a common pool of knowledge such that those are absorbed back into the design, and a cyclical pattern of improvement, of building on top of former work occurs. So this allows us to get away from reinventing the wheel and truly build upon each other's work.
However, a powerful means to share information in open source plans wouldn't be very significant if we couldn't actually manufacture them. Up until a few years ago, we had a choice between two types of tools: mass production tools and manual tools, nothing in between. Things began to change in the 1980s with the maturation of digital fabrication tools, 3D printers, laser cutters, CNC mills, machines that produce physical objects from digital designs. What is interesting about these technologies is their flexibility. While it takes a conventional factory months to switch from the production of one good to another, with digital fabrication tools we can make toys in the morning and chairs in the afternoon. And for the same reason, the cost of producing one single item is not very different from the cost of producing 100. But if these technologies have been around for 3 decades, why haven't we seen more of them sooner? Well, just like the mainframes of the pre-personal computer days, digital fabrication tools were at first extremely expensive, accessible only to large organizations, and used mostly for prototyping. In 2004, Adrian Boyer, a professor in the UK, decided it was time to make digital fabrication accessible to the common man. So he began designing a compact and highly affordable 3D printer capable of manufacturing several of its own parts and all sorts of plastic objects. He named it RapRap and released it as open source. With the plans available online, hobbyists around the world began making self-replicating devices in their basements and using them to make parts to make more machines. And a few short years after that, Adam Mayer, Zach Hokan, and Brie Pettis simplified Adrian's design and created another highly affordable machine based on it. Their model cost $850 at a time when the cheapest commercially available 3D printer cost over $15,000. So excited with the results, they quit their jobs and with barely any initial investment, launched a company to sell their 3D printer as kits. They are now one of the most successful manufacturers of personal 3D printers. And after that, the desktop 3D printer market, which didn't exist until then, exploded. 3D printers were just the beginning. Soon, open source laser cutters and CNC mills appeared as well. LaserSaw, the laser cutter pictured here, cost $7,000 compared to $30,000 for the proprietary ones. So RepRap, MakerBot, LaserSaw launched the wave of change that is beginning to put production in the hands of the common man. And this combination of open source plans with access to fabrication tools is giving rise to a new breed of industry, the open source industry. So who are these open source industrialists who believe in the power of collaboration and are building businesses on top of it? They are the makers of cars like Local Motors and WikiSpeed, with their 100 mile per gallon 5-star crash rating car. They are the makers of houses like WikiHouse and Architecture for Humanity, the makers of aerial drones like DIY drones, of oil spill cleanup drones like Prote, and of subaquatic drones like OpenROV. They're the makers of toys like Littlebits, and the makers of construction and agriculture machinery like open source Ecology.
Okay. As founder of Open Source Ecology, I'd like to share my story on that. So, at Open Source Ecology, we've identified the 50 most important machines that we think it takes for modern life to exist. The things we rely on every day, whether we know it or not, things like tractors, ovens, circuit makers. Then we create an open source, do-it-yourself version that anyone can build and maintain at a fraction of the cost. We call this the Global Village Construction Set. So, are we reinventing the wheel here? Well, yes. So, let me tell you a story. So, I finished my 20s with a PhD in fusion energy, and I discovered that I was useless. I had no practical skills. The world presented me with options, and I took them. I guess you can call it the consumer lifestyle. So I started a farm in Missouri and learned about the economics of farming. I bought a tractor, then it broke. I paid to get it repaired, then it broke again, and pretty soon I was broke too. So what I realized was that the truly appropriate low-cost tools that I needed to build a sustainable farm and settlement just didn't exist yet. I realized I would have to build them myself. So I did just that. And I tested them. And what I found out was that industrial productivity can be achieved on a small scale. So then I published the 3D designs, instructionals, schematics, and budgets on a wiki. Then contributors from all over the world began showing up, prototyping new machines during dedicated project visits. So far we've prototyped 15 of the 50 machines, and the project is taking off on its own. People have downloaded our open source plans, and now there's over a dozen replications in 5 countries around the world. So the next step is to demonstrate that each one of these machines can be built in a single day of production in a basic fabrication shop.
So it may seem strange that industrialists are giving away the plans for their products, but that's exactly what's happening. It is happening because it's a better research and development method. With the plans available online, anyone, including their competitors and customers, is free to customize and improve them. In turn, these improvements become public and everyone benefits, leading to faster development and more appropriate technologies all around. So the same collaborative approach that worked for the Cornish steam engine is now fueling the open source industry. But how do they stay in business if they give away their designs? Well, the answer is deceptively simple. They make things and then they sell them. And then they stay ahead of the competition, not by holding a monopoly, but by offering the best products and services at the best prices. And they are becoming very good at it, with companies such as SparkFun, a producer of open source electronics with 140 employees and their own production facilities, reporting revenues of over $75 million for 2012. At the turn of the 19th century, the Cornish miners demonstrated the power of open collaboration. However, despite this early warning that patents may not be as beneficial to invention as initially thought, the number of patents continues to grow. And now, just like the Cornish miners did 200 years ago, we are again questioning the role of intellectual property. In recent years, respected jurists and economists alike have come to the public's attention with concerns that the current intellectual property system may in fact be stalling economic growth and hindering innovation. Is it useful that in this day and age, spending by Google and Apple on patents exceeded spending on new products, development of new products?
So efficiency and automation are even more important today than they were 200 years ago. And the good news is that we have a lot of those tools available to us. So lower barriers to production, better means, better access to the digital fabrication tools means that we can create more sophisticated businesses on a small scale. So here's an example of a car company for electric cars. This is Tesla Motors with their army of industrial robots. Now that's not open source, but the point is that Tesla Motors can do, say, 100 cars of production per week, as opposed to like 10,000 per day for a standard assembly line. And in open source ecology, we're pushing the limits of this even further in that we've built one of our machines, the automated compressed earth brick press, in a single day of production. So how does that work? We took 10 people and people who might have not even met each other and people who have never built something like remotely like a construction machine before, but with our open collaboration methods, including the open design, including IKEA-style fabrication diagrams, and open blueprints, of course, and access to a CNC laser cutter that allowed a single person to cut out all the parts readily and accurately. So this is an example of the kind of promise where if this model is truly working, then we can talk about production efficiencies of design such that this may indeed become a model, a preferred model of production, of design for standard companies. So one day may not seem like much compared to the millions from mass production, but the idea is that thousands of such microfactories can become the new engine of production in today's world. That's the whole promise of Industry 2.0, the concept of globally sourced, globally collaborative design and locally adapted digital flexible fabrication.
So mass production became desirable because churning out thousands of identical items lowered the cost of production significantly. But if we can now have cost-efficient, small-scale production, then the appeal of the one-size-fits-all for consumers is considerably decreased. Another interesting effect of this convergence of democratizing technologies with new models for collaboration lies in the distribution channels. While a century ago small-scale production was confined to local markets, nowadays the internet allows producers at all scales to distribute worldwide. This is what Chris Anderson calls the long tail. As the cost of reaching consumers drops dramatically, our markets are shifting from a one-size-fits-all model of mass appeal to one of unlimited variety for unique tastes. This has been shown from DVDs on Netflix, to songs on iTunes, to advertising on Google. And the same applies to physical goods. This is not just a property of digital marketplaces, it's a new business model that is only beginning to show its power. So we envision a global supply chain made up of thousands of small producers, manufacturing quality goods they are proud of, distributing them locally and globally, and collaborating with each other to create better, faster, and more meaningfully. Enter the economy of meaning. What happens when people gain access to tools that make them more capable, powerful, and productive than ever before? Can anyone make anything anywhere? Can we accelerate innovation to solve problems faster than they are created? The long tail is really about the economics of abundance.
Yeah, so in the overall scope of human progress or innovation, it may be said that we have mastered production. And the next phase is to master distribution. If we can achieve that, the new economy will begin to revolve around different questions about what are our deepest motivations and desires, and then how does the new economy give us the means to achieve them? It will be an interesting point when we transition from mass jobs to mass meaning. I like Daniel Pink's comment on this in his TED Talk about the surprising science of motivation, in which he talked about that people are not really motivated by a bigger reward, that the real intrinsic motivation comes from three basic values, and that is autonomy, mastery, and purpose. Autonomy is the urge to direct our own lives. Mastery is a desire to get better and better at something that matters. And purpose, the tendency of us to do what we do in service of something greater than ourselves. So as our economy becomes more and more sophisticated, these three properties now become the new driver of the economic system, and therefore of the world. So I challenge you to collaborate, to open up your know-how, share, and do that bravely, and possibly no fear in that. So the rewards are huge. It's about the opportunity to reintegrate communities, to rebuild economies, to disrupt manufacturing, to regain ecology, and to unleash productivity everywhere and leapfrog through old problems while leaving nobody behind. Okay, thank you. Okay.